Hi, it's Ms. Richmond. We're going to talk about systems of equations by elimination. Sometimes this is called linear combination. First, we'll start with an example similar to what we've done, where you have two equations, two variables, and if you look closely, you can see that one of them is negative 6x and one is positive 6x. So as you know, if we take these two equations and simply add them together, then what will happen is that the x's will drop out, and so we will end up with a nice simple equation of 7y equals 28 because the x's drop out, and if we divide by 7 on both sides, we'll get y equals 4. So that's the value of y. And now we need to take this value of y and substitute it into one of the other two equations. I'll do this one here simply because the x is positive. I could do either one. So this would give me 6x plus 5 times 4, because my y value is 4, equals 32. So this means 6x plus 20 is 32. Subtracting 20 from both sides gives me 6x equals 12. So of course that means that the value of x is 2. And if I go back and plug this in to check for each of these equations, for the top one, I would have negative 6 times 2 plus 2 times 4 equals negative 4, which would be negative 12 plus 8 is negative 4. That one works. And then on the second one, 6 times x is 2 plus 5 times my y value of 4 should equal 32. And sure enough, 12 plus 20 is 32. So that one works. So I have found the answer to the problem, and it would be x is 2 and y is 4. Here's a second example. This one's a little harder because notice if I just add these equations, neither variable will drop out. And if I subtract them, again, nothing will drop out because my coefficients are different. So I need to get a little bit clever and look at the coefficients. If I look at the x's, you might notice I have a 2 and a 4. If I just take this top equation and multiply it by 2, remember by the multiplication property of equality, I can multiply any equation I want by any number I choose. So in this case, if I multiply everything through by a negative 2, let's see what happens. That's going to give me negative 4x plus negative 6y equals negative 18 for this top equation. The bottom one I can just rewrite the same way it is, which would give me 4x plus 8y equals 28. Now the reason, of course, that I chose to multiply by negative 2 was so that the x's would drop out. So I noticed that 2 times 2 would give me this 4. And then if I multiply it by a negative 2, that will give me a negative 4x for the top equation and a positive 4x for the bottom. So when I add these together, of course the x's drop out, and I end up with 2y equals 10. So y would equal 5. So that's the y value. To find the x value, I can take either equation I want and plug in my y equals 5. Let's take the original top equation. I had 2x plus 3y equals 9. And if I put in the 5 for the y, I would have 2x plus 3 times 5 equals 9. So 2x plus 15 equals 9, subtracting 15 from both sides. And I end up with 2x equals negative 6, so x would equal negative 3. Let's go ahead and check that. So the first equation was 2x plus 3y equals 9. So if I plug in my values, I'd have 2 times negative 3 plus 3 times 5 equals 9. And this is negative 6 plus 15 equals 9. And that is true. My second equation was 4x plus 8y equals 28. Again, plugging in my x and y value. 4 times negative 3 plus 8 times 5 should be 28. 4 times negative 3 is negative 12 plus 40 equals 28. And that is also true. So therefore, my values are correct, and the answer to my problem would be x is negative 3, y is 5. Now remember, this one worked out because I could easily see what to multiply by so that I could make the coefficients of the x be exactly the same except with opposite signs. Let's look and see how that works in a problem that's a little more challenging. Here we have an example of a systems problem where there's no obvious number to multiply by. This is a more typical problem, but it's a little more challenging. So the first thing to do is to pick which variable you'd like to make drop out, and it really doesn't matter which one. In this case, let's make y drop out. So I'm going to off to the side just write down so I remember that I'm going to drop the y. So I look at the coefficients of y. I've got 5 and 4. Remember, my goal is to make these drop out. So I want to find numbers I can use to multiply so that I end up with coefficients of y that are the same, except for the signs. So if you look at the 5 and the 4, what you want to do is find a number they both go into evenly. That's also called the least common multiple. So what we're looking for is we're looking for the least common multiple target of 5 and 4. Okay, so what's the least common multiple of 5 and 4? Well, that would be 20 because 5 goes into 20 and so does 4. So my target that I'm looking for is 20. So I want to multiply these equations so that each of them has a coefficient of y that is 20, but I need the signs to be opposite. So let's see, 5 times what gives me 20? Well, 5 times 4, of course. So if I multiply this one by 4, remember to multiply every term in the equation. So I get 4 times 3x is 12x plus 20y, notice that is my target, my LCM target, equals 4 times 17, which is 68. And now for the second equation, I really want 20, but I want it to be a negative 20, so that when I add them, the y's drop out. So right now this is a positive 4. If I multiply by negative 5, that will give me a negative 20y. And again, I need to remember to distribute and multiply this negative 5 by each term of the equation on both sides. So I'm going to get negative 35x minus 20y. Notice how these drop out. that means I'm on the right track, equals -5 times -14 is a positive 70. So now when I go to add my equations, the y's indeed drop out, and here I will have a negative 23x equals, this is 8 and this is 13. So I get negative 23x equals 138. That seems a little tough. So I'll do a little guess and check off to the side. Let's see, 23 times 5, that's 15, carry 1, 10, 11, so 115. That's too small. Let's try 23 times 6. 23 times 6, 18, carry 1, 12, 1. Perfect. So if I divide both sides by -23, I will get x equals -6. That's my x value. Now I need my y. Well, I know that 3x plus 5y is 17. So that means 3 times 6 plus 5y is 17. This is 18. -18, sorry, because I had -6 plus 5y is 17. So that means if I add 18, I end up with 5y equals 35. So y is 7. So my answer to my problem would be -6, 7. And if I go ahead and plug that in, I will find out that that works. Let's just do it quickly to check. So I've got 3 in the first equation times -6 plus 5 times 7 equals 17. So -18 plus 35 equals 17. Yes, that's correct. And in the second one, I have 7 times -6 plus 4 times 7 for y should equal -14. So this is -42 plus 28 equals -14, and that's also true. So yes, indeed, my answer is -6, 7. So let's just look back at what we did. We decided which variable to drop. We chose to drop y. We found the least common multiple of the coefficients 5 and 4. The least common multiple was 20. That was my target. I wanted one of the equations to have a positive 20y and one to have a negative 20y, so that when I add them, the y's do in fact drop out. So I multiply the top one by 4 and the bottom one by -5. Now you'll have a chance to try some on your own.